Good morning children. In today's class we are going to discuss the variety of applications of partial derivatives in business. Production. The concern of every organization. Production function let me call capital P. That depends on many factors like labor say L, machinery say M, raw materials say R, and capital say K. If I consider production as a function of capital K and labor L alone, it is becoming two variables restricted to our syllabus. So when I have the two variables and if the production function is a homogeneous function of degree 1, then Euler's theorem states that K dou P by dou K plus L dou P by dou L equals to P. Here instead of U in the previous exercise we put P. Instead of X and Y, I can put L and K. So, X dou U by dou X we learn. Now, I write L dou P by dou L. Y dou U by dou Y we wrote. Now, we are writing K dou P by dou K. And the total should give me N into U. Here, the degree is 1 and U is P. So, 1 into P is P. Now, in this exercise, we are going to do problems based on capital and labor for the function of production. Exercise 6.5, question number 1. Find the marginal productivities of capital K and labor L. If P equals 8L minus 2K plus 3K square minus 2L square plus 7K into L. When K is 3 and L is 1. Marginal tells me differentiate. Since there are two variables, I should go with partial derivative. So, dou P by dou L. This is marginal productivity of labor. Now, I differentiate P partially with respect to L. What does it mean? K and K square, K power 3, all that, keep it as constant. 8L, 8 into L will become 1. I am doing with respect to L. Like X becomes 1 in the previous exercise, now L will become 1. If X square becomes 2X, I will write L square becomes 2L. The same idea of differentiation, but now the letter has changed. Minus 2K. Here L is not coming. It will become 0. 3K square. Again L is not coming. It will become 0. Minus 2 into. Here L is coming. L square will become 2L plus 7 as it is, like coefficient. K also as it is. I am doing only L, that becomes 1. So what is dou P by dou L? It is 8 minus 4L plus 7K. We are given some values, say K is 3 and L is 1. As I substitute, dou P by dou L is 8 minus 4 into 1 plus 7 into 3. As we simplify, it is 8 minus 4 plus 21. That is 25. So let us take and write the answer at the end. This is marginal productivity of labor. The same pattern. Let us do marginal productivity of capital. That is differentiate P with respect to K. Now L and L powers will become 0 if they come alone. 8L, no K at all, it will become 0. Minus 2, K comes, so K becomes 1. Plus 3, again K square will become 2K. So now I apply formula only for K. If L comes alone, it will become 0. Plus 7KL, both are coming. I do with respect to k. So keep 7 and L as it is. K will become 1. So what is my answer? Dou P by dou K equals minus 2 plus 6K plus 7L. As I substitute the two values, K equals 3, L equals 1. Dou P by dou K equals minus 2 plus 6 into 3 plus 7 into 1, simplifying which minus 2 plus 18 plus 7, that is 23. Let us take and write the answer. Marginal productivity of labor is dou P by dou L, that is 25, and marginal productivity of capital is dou P by dou K, and that is 23. Hence the problem. Question number 2. The production of the firm is given by P equals 4LK minus L square plus K square. Where L greater than 0 and K greater than 0, prove that L dou P by dou L plus K dou P by dou K equals to P. As I look at it, it looks like Euler's theorem. So, we can use Euler's theorem and prove the result. For which, find out the degree of the function. So, wherever K is coming, let me put Tk. Wherever L is coming, TL. As I substitute 4 into TL into Tk minus L square becomes T square L square, K square becomes T square K square. T into T is T square. So, in all the terms T square common, if I take it out, 4LK minus L square plus K square. So, it is T square into the given function P. So, I can declare P is homogeneous in L and K of degree 2. If I use Euler's theorem, what does Euler's theorem state? If it's a homogeneous function of degree n, then x dou u by dou x plus y dou u by dou y equals nu. In this problem, wherever u is coming, I have to put p because the given function is p. Wherever x is coming, I have to put L. So, the function is L into dou P by dou L. Wherever y is coming, let us put K. K into dou P by dou K. So, let us read Euler's theorem. L into dou P by dou L plus K into dou P by dou K equals N into P. In this problem, N equals 2. So, if I apply, my answer is L dou P by dou L plus K dou P by dou K equals to 2 into P. By using Euler's theorem, we have verified the result. There is yet another procedure. Find out dou P by dou L, dou P by dou K. Show it is equal to 2P, the result. Without using Euler's theorem also, you can try. The second method, without using Euler's theorem, how to prove it? Find out dou P by dou L. So, we are differentiating with respect to L. 4K as it is, L becomes 1. L square becomes 2L, K square becomes 0. My answer is 4K minus 2L. I need to multiply dou P by dou L with L. So, L into dou P by dou L is 4KL minus 2L square. Call it as number 1. Find out dou P by dou K. Keep 4L as it is. I do with respect to K. So, K becomes 1 minus L square 0, K square 2K. It is 4L plus 2K. This we multiply by K as in the question. K dou P by dou K is. Multiply the terms by K. 4L into K, 4KL. 2K into K, 2K square. Call it as number 2. Let us add 1 and 2. L dou P by dou L plus K dou P by dou K equals, adding these two, 4KL minus 2L square plus 4KL plus 2K square. In all the terms 2 is common. If I take it out, it is 2KL minus L square plus 2KL plus K square. Or rewriting it, 2KL plus 2KL is 4KL minus L square plus K square, which is nothing but the original function P. So I deduce 2P. Starting with L dou P by dou L plus K dou P by dou K, we have arrived at 2P. So we have done two methods. Method 1, we have used Euler's theorem. Method 2, we have just differentiated partially with respect to L and K, and we have checked the result. Both methods are correct. You can choose whichever you prefer. Question number 3. If the production function is z equals to 3x squared minus 4xy plus 3y squared, where x is the labor and y is the capital, find the marginal productivities of x and y when x is equal to 1 and y is equal to 2. Marginal tells me differentiate. Because there are two variables, we put partial derivative, dou z by dou x. 3 into. We differentiate with respect to x alone. Treat y as a constant. X squared becomes 2x minus 4y as it is, x becomes 1 plus 3y squared becomes 0. Dou z by dou x is 6x minus 4y. Now they have given x is equal to 1, y is equal to 2. So dou z by dou x equals 6 into 1 minus 4 into 2. That is 6 minus 8, which is minus 2. So I get dou z by dou x equals to minus 2. Now we do z with respect to y. 3 into x squared is a constant, so the entire thing becomes 0. Minus 4 into, I am doing with respect to y. Keep x as a constant. So minus 4x as it is, y becomes 1. Plus 3 as it is, y squared becomes 2y. Or we get dou z by dou y is minus 4x plus 6y. When x is equal to 1 and y is equal to 2. Dou z by dou y equals minus 4 into 1 plus 6 into 2, or it is minus 4 plus 12, which is 8. Let us take and write the answer. Marginal productivity of x is minus 2. Marginal productivity of y is 8, and hence the problem. Question number 4. For the production function P equals 3 into L power 0.4 into K power 0.6. Find the marginal productivities of labor and capital when L is 10, K is 6. To ease our calculation, they have given you 0.6 power 0.6 and 1.67 power 0.4 answers. Given P is 3 into L power 0.4, K power 0.6. Marginal productivity of labor is dou P by dou L. Now I do with respect to L. Keep 3 as it is, K power 0.6 as it is. Let us remember the formula. X power n derivative is n x power n minus 1. Here L power 0.4. How will I write it? 0.4 L power 0.4 minus 1. So here x value is L, n value is 0.4. As I apply 0.4 L power 0.4 minus 1. 3 into K power 0.6. 3 into 0.4 we can multiply. 3 into 0.4 is 1.2. L power 0.4 minus 1 is minus 0.6. Or I can say 1.2 K by L the whole power 0.6. Now let us substitute. What is L given 10? What is K given 6? As I substitute, dou P by dou L is 1.2 into K value 6, L value 10, the whole power 0.6. Or we get 1.2 into 6 by 10 is 0.6, the whole power 0.6. We shall use this answer. So it becomes 1.2 into 0.736. As we multiply, we get dou P by dou L equals to 0.8832. Now let us find out dou P by dou K. 3 will come as it is, L power 0.4 as it is. Apply the formula only for K. It is n x power n minus 1 pattern. Here the power is 0.6. 0.6 K power 0.6 minus 1, or 3 into 0.6 is 1.8. L power 0.4 K power 0.6 minus 1 is minus 0.4. Bring it down. It is 1.8 into L by K the whole power 0.4. Negative power comes down as positive. Now let us substitute. L equals 10, K equals 6. Dou P by dou K equals 1.8 into 10 by 6 the whole power 0.4. It is 1.8 into 10 by 6 is 1.67, the whole power 0.4. This value given in the question, let us make use of it. 1.2267 into 1.8 gives us dou P by dou K equals 2.20806. Let us take and write the answers. Marginal productivity of labor is 0.8832 and marginal productivity of capital is 2.20806, and hence the problem.